Hello guys, welcome back to this advanced level combined mathematics YouTube platform. Through this, that's paper out problem series. Yes, today we'll see a nice question. See, the problem is actually binomial part 1 plus x to the power n, c naught, coefficient 0, coefficient 1x plus coefficient 2x squares, coefficient and so on, c1, c2, c3 up to cn power x to the power n. Binomial expansion generally 1 plus x to the power n. And later part sigma r square minus 3r plus 1 into cr equal 2 to the power n minus 2 into f of n. So up to now your usual pattern, sigma or series question or binomial theorem. See later part, alpha beta are the roots of fx equals 0. Alpha and beta are the roots of equation fx equals 0. Therefore maybe fx is a quadratic equation because of two solutions. Then alpha plus beta, alpha into beta. But here the problem is find the value 2 alpha plus 3 beta. Answer either 14 or 11. Also show this sum of the cubes. A nice workout. See, this question belongs to what? Binomial theorem or series problem, something like that. Or finally quadratic equation. That is, I said, my paper out problem says a fantastic question. Okay, we'll see. I'll refer some of our theory notebook and see what about the binomial coefficients, properties of binomial coefficient. See that 1 plus x to the power n. The any power, basically we start from the primary order classes, a plus b all things square, a plus b cube, a plus b power 4 by Pascal's triangle. You can expand many more. That later a is like a 1, b is x, 1 plus x to the power n format. This can be expand, the actually nc naught plus nc 1x plus nc 2x square, okay, and up to ncn x to the power n, right? Or you can avoid the n, no problem. Without n also we call c naught plus c1x plus c2x square plus cn that up to n, right? That also can show without the nc naught. Various pattern c, let's go show given here, c naught c1x plus c2x square, power increasing, finally cn x to the power n, right? Now we refer some properties of algebraic this binomial expansion. So many proof for there if you refer our notebook of the theory class. I will show a few here. See what happen if we put x4 1. If we put x4 1 here, what the answer? 1 plus 1 2 to the power n c naught plus c1 plus c2 plus c3 and so on cn. See, very important. So what is binomial expansion or coefficients? Sum of all the coefficient answer up to n terms 2 to the power n. c0, c1, c2, c3 up to cn, answer 2 to the power n. If you put x4 2, there's another pattern value. x4 3, x4 minus 1. What is x4 minus 1? Here 0. But this side you have something odd numbers, even numbers comes, negative, positive combination. So you can check some pattern of this binomial part, right? So here is shown one pattern. This is a one nice case 2 to the power n if x is 1, right? Okay, see another format. 1 plus x to the power n equals c naught plus c1x plus c2x square and so on. Do some calculus knowledge, differentiate respect to x, this with respect to x, differentiate both sides with respect to x. I show here, power differentiation, 1 plus x to the power differentiation, put the power in front and deduct 1 to the power, right? And other side, C naught is a number, only one coefficient, there is 0. 5x differentiation 5, 7x differentiation 7, C1x differentiation C1, C2x square differentiation 2C2x, is it? Next, C cube, C3x cube differentiation 3C3x square, is it? And so on. What is finally NCN x to the power n minus 1, right? Put the power in front, NC x to the power n minus 1, differentiation. Here also you can put x41 and c, and the value put x41 here, 1 plus 1, 2. So 2 here, n, 2 to the power n minus 1, is it? Put x41, 2, n minus 1, and there's the n. Here put x41, c1, 2c2 plus 3c3 and so on, plus ncn x to the power 1. We put n41, x41, that is 1. So I'm showing binomial theory, 1 plus x to the power n. The answer is provided. Put x41, this one identification of theory. Differentiate the given expansion respect to x, and put x41, c1 plus t2, c2, 3c3 and so on. The answer 2 to the power n minus 1 into n. It's also another, what do you call, identification of this binomial coefficient. Again, if I differentiate it, check will you, if I differentiate this one, if I take the here, not clearly all the parts, differentiate this once again respect to x, differentiate, power differentiation put in front, so n into n minus 1, 1 plus x to the power n minus 2, okay, write the power n into n minus 1 and deduct 1 to the power, okay. But the other side, 0, here 0, that is 2c2 plus 3 into 2 into c3x, is it? Write the power in front, 3 into 2 into x. But the other one, here comes next one, 2, 3, 4 x cube, that is 4 into 3 into c4 x cube, x square. Here next one, x cube differentiation, x square and so on. The last, n into n minus 1 cn x to the power n minus, long work, keep it properly. Again differentiation. So what happened if you put x41 here, put x41 for this series, put x41, 1 plus 1, 2, n into n minus 1, put x41, 1, 1, 2, 2 to the power n minus 2 equal, put x41, 2c2, put x41, 3 into 2 into c3, put x41, 4 into 3 into c4 and so on, right? Okay, this is the technique of this question. I covered all the binomial parts and how it vary. Now I try to resolve the problem how this becomes Fn. So this is equal to Fn. So once you know Fn, then you know Fx. Hereafter simple, I think a quadratic format. Okay, come back the question here. Can I expand this problem properly in terms of the sigma summation? Put R for naught plus R for 1 plus R for 2 plus R for 3 plus up to R for n, right? So can I write this one? It's equal sigma. Take the R out, R minus 3, okay, R minus 3, then yes, R square minus 3R, and plus 1, completely CR, okay. I use the R out, it becomes R into R minus 1, but we have the R minus 1. Wait, see some the polynomial pattern is R minus 1 now. See, can I write this one? R into R minus 1. So R square there, okay. Minus R, but minus 3R. Therefore, minus 2R plus 1 completely CR, right? The first step very important. So can I write this one was 1, 1 less, 5, 4, 6, 5, R into R minus 1. You simplify the problem is this R square minus R minus 2R minus 3R, right? Yes, plus 1. Okay, right. Now, can I write that separately with the sigma notation? Sigma R into R minus 1 minus 2 into sigma R plus CR. I think all the parts consist of CR. They also CR. Check that. R into R minus 1 CR minus 2R CR. Finally, 1 times CR. Boundaries 0 to n, right? Boundaries 0 to n. Okay. 0 to n. So they say later is completely equal to what? 2 to the power n minus 2 fn, right? It's completely equal to 2 to the power n minus 2 f of n, right? Okay, now we come to the problem now. If I show few terms, see, but you can write separate and see, put R for 0, it's completely that is 0, put R for 1, 0, put R for 2, I show that work. Okay, I'll raise this and see. So we have to use this theory part, polynomial properties here, coefficients properties here, right? Okay, I'll show this one, see what the answer is. Sigma R into R minus 1 CR R equal naught to n. What the answer of this? Put R for naught, completely naught, right? Put R for 1, naught. Put R for 2, 2 into 1 C1, sorry, C2. R for 0, R for 1, R for 2. Put R for 3, 3 into 2 C3. Put R for 4 plus 4 into 3 into C4, and so on. Put R for n, n into n minus 1 Cn. So what the answer of this? See the problem somewhere available. 2 into 1, 3 into 2, 4 into wow. So that answer n into n minus 1, 2 to the power n minus 2, right? So this value belongs to, I differentiate second occasion and put x41. Copy that clearly. So therefore, this answer is here n into n minus 1, 2 to the power n minus 2, right? Okay, come back similar part. What is RCR? Put R for 0. First is 0. 1C1 plus 2C2 plus 3C3 up to that. 1C1, 2C2, 3C3 up to that. Answer this. Okay, therefore this expansion next part, here negative 2 into this completely 1, we put R for 0, first term 0, R for 1, 1C1, 2C2 plus 3C3 plus 4C4 up to n terms, this one, 2 to the power n minus 1 into n, right? 2 to the power n minus 1 into n. That's the answer of that part. Finally, positive, okay? What is CR? That means apply C naught plus C1 plus C2 plus C3. That is check the beginning. I put x41, put x41, 2 C naught, C1, C2, C3. 2 to the power n, right? This is 2 to the power n. That's all. It's completely equate to the other side. What that? 2 to the power n minus 2 f of n. Okay. Now from here, try to find what is 2 to the power fn. We'll calculate what is fn equal. So from that, binomial part is over after finding the fn. From that, you can find what is fx, complete your alpha beta combination. Okay, can I use some simple pattern where there is we use take here n into n minus 1, okay, 2 to the power n minus 2, can divide by 2 to the power n minus 2 also. Otherwise, can I take some common part here? Yes, minus bases equal at the power, so that is 1 to n, okay, plus 2 to the power n, the other side 2 to the power n minus 2 f of n, long work. So furthermore, n into n minus 1, my target hereafter to find what is fn. So take here, can I do minus sign, 2 to the power n now, that is n minus 1, right? Equal 2 to the power n minus 2 f of n. Right, now divide by 2 to the power n minus 2. Divide by 2 to the power n minus 2. There is cancel n into n minus 1, right? Here divide 2 to the power n minus 2. 2 to the power n minus 2 divide, you know, bases equal, dividing, subtract the power, therefore it's come 4. 4 into n minus 1, okay. So the other side, that is fn. Wow. See how the question is built up. A nice workout. Shown proper form of a binomial expansion and binomial properties, coefficients properties. Okay, now you can rearrange what is f of n. F of n square, okay, n square minus 5n, is it okay, plus 4. This is fn, right? Therefore, you know what is fx. So what is fx, and the roots are alpha beta. I think this is slightly can be factorized and find the answer, not a hard quadratic equation part. Therefore fx equal, x square minus 5x plus 4. If this is 0, you can find the answers x minus 4, Is it okay? Yes, nice work. Therefore, x equal 4, x equal 1. That means alpha equal 4, O alpha equal 1, or beta equal 1, or beta equal 4. Is it two answers? Alpha, beta, right? Then check if the answer comes clear, then the problem is solvable, right? Therefore, the A part answer 2 alpha plus 3 beta. Is it check if you put alpha here 4, then 8. In that case, beta is 1. Yes, 3. Answer is 11. 8 plus 3 is 11. If you apply the other form, alpha 1, beta 4, alpha 1, beta 4, answer is 14, right? And now sum of the cubes. What is alpha cube and beta cube? Alpha cube plus beta cube. Alpha is 4 to the power 3. Beta 1 cube, yes, 65. See? So nice part, the combination of binomial, something, some sort of series summation, and finally quadratics is a simple O-level type of quadratics. Okay, well, please subscribe. I hope you enjoyed this my video series. Please subscribe and share. We'll see you next time with an attractive paper out, all expecting in your future pure maths, applied maths, further mathematics, or advanced higher maths papers at Excel, Cambridge, any type of problem solving, or IITG Indian papers, anything. So more suit of a combined mathematics students. So please subscribe and share. Bye.